Good day, ladies and gentlemen, boys and girls, friends and neighbors. Today we're going to talk about arc lengths of circles. This is a very important pre-lesson to discovering what a radian measure is in trigonometry. So we're going to go back in time and talk about arc lengths of circles in geometry. So this is mostly a geometry topic here. Is arc lengths of circles. This something that we should have covered in geometry. And before we talk about arc lengths, we better make sure we have our heads wrapped around what the heck measures of arcs of circles. The difference between the measure of the arc of a circle and the length of an arc of a circle. So here I have a circle. The center of the circle is 0, and I have AB on the circle. And here we can talk about this arc right here. This arc AB. Arc AB, and we denote arc AB as AB. This is the geometric way we write arc AB, and it is a minor arc. The arc is less than since the measure of the arc is less than 180 degrees, we call it a minor arc. Okay, and let's just, for this angle right here, let's just assume that that angle for a brief moment in time is 30 degrees. So we're going to say the measure of angle AOB is equal to 30 degrees. Well, we did talk about the measure of an arc, and the measure of an arc is the same as the measure of the central angle that subtends that arc, i.e. that intersects that arc. So if we have angle AOB is equal to 30 degrees, then yes, the measure, and this is how we're going to denote the measure of arc AB, the measure of arc AB then is also going to be 30 degrees. What I want to point out here is if I take another circle, and I'm going to take a bigger circle, and I'm going to fix that circle so that we have two concentric circles. Let me scoot my diagram down now. These are two concentric circles. Concentric circles simply mean that they have the same center. They are concentric. And if on this bigger circle, if I look at these 2 points on this bigger circle, and we're just going to, for purposes, EF, I notice that the measure of angle FOE is also 30 degrees. So it doesn't matter how big, how dilated, or how small your circle is. If your circles are concentric, that is, if they have the same center, the measures of the arc will be the same. So the measure of angle FOE is 30 degrees, and so therefore the measure of arc EF is also 30 degrees. What I'd like to point out here is that the lengths of these arcs are clearly different, because if I talk a length as a distance, if I talk about the length of AB, this is the length of AB. That's the length of AB. The measure of AB is 30. We don't have a formula for the length of AB yet, but we will. And this clearly, this is the length of arc EF. Clearly, the distance E is from F on the circle, on the bigger circle, is longer than the distance from AB. So although arcs can have the same measure, they will have different lengths. That is, if the circles have different radius. And clearly, these circles have different radiuses. And the next thing I'd like to point out, if I have a circle, and it doesn't matter what the radius is, if I measure all the way around the circle, and we're going to use this down the road, I'm going to change the color of my radius here. If I go all the way around the circle, then a circle measures all the way around 360 degrees. And we've just reviewed that recently. So that one didn't. I should have taken that circle. Let me get him out of there and do another one. I think I have the same color going on. I do. If I go all the way around that circle, that's 360 degrees. The other thing I would like to note, if I change the color again of my radius, and if I go halfway around the circle, the measure of that arc is going to be 180 degrees. And I can measure different arcs of the circle. Let's just do another one right here. Bam. And the measure of that arc right there is going to be 90 degrees. And we've talked about the measure of arcs before as well. Again, the objective of this video is to find out lengths of arcs, arc lengths of circles. So we've had a little brief review on measures of arcs. So let's go to the next slide and see what's up for the next slide. So in order to understand that the formula that we're going to use to find the length of a circle, we have to recall the circumference of a circle, the formula for the circumference of a circle. And what in the world is the circumference of the circle? Well, the circumference is the distance all the way around the circle. It's the length of the entire circle. It's the distance all the way around the circle. And we remember the very common formula for circumference is 2 pi r. And maybe in some of your geometry classes you develop this formula, but that's for a geometry class. Today we're just going to use that formula. So the formula to find the circumference of a circle is 2 pi r, where r is the length of the radius. So we can define r as the radius itself as the segment or the length of r. And for this formula, we're going to talk about r as being the length of the radius. And for this particular example, I have r is equal to 4. If r is equal to 4, then the circumference of this particular circle is going to be 2 pi times 4. That's going to be 8 pi. So the circumference of a circle with radius 4 is going to be 8 pi. We could certainly approximate this if we would like, and we just take 8 and multiply it by pi with our calculator. This is the more exact answer, but if I take I and multiply it by pi, I'm going to get 25. This is approximately 25.132. 7, if you will. We've been using 3 or 4 decimal places in our discussions mostly, so we're going to continue to use 3 to 4 decimal places. Or if you want to write it exact, you can write it as 8 pi. So that's the circumference. So the question then is, how about if I look at part of that circle, what is going to be a length of an arc? So I'm going to erase this a minute. And if I just take this arc right here, and I'm going to go straight up, where this is going to be a 90 degree. Clearly, if I go all the way around the circle, it's 360 degrees as it is. If I go 90 degrees, and I have gone 1/4 of the distance around the circle, because this is 90 degrees. So we should think about then, if I label this, let's label this point here A, and this point here B, where the measure of arc AB is equal to 90 degrees. 90 degrees. What do you think the length of arc AB would be? Think about that for a moment. Pause the video. And if you've had time to think about that, if the measure of AB is 90, which is 1/4 all the way around, then it seems reasonable then that the length of this arc AB is going to be 1/4 of 8 pi, which is going to be 2 pi. And you would be absolutely correct. So the length of AB is 2 pi. What does that mean? That means this distance here is 2 pi. That distance is 2 pi. We know the distance all the way around the circle was 8 pi. So if I only go 1/4, that distance is going to be 2 pi. That's very interesting. So I'm going to do one more with this particular example, one more arc, and see if you can figure out what the length of that is. What if I put this point here in C? Let me erase some things. This is certainly getting a little bit busy. We can't forget that this is the center of the circle. What if I let this angle here be 90 degrees? And what if I talk about this? The measure of arc BAC. Now this is a major arc because it's greater than 180 degrees. So what I'm talking about then is this arc right here. Well, I think we should be able to figure out pretty easy that the measure of this major arc because it's greater than 180 degrees, BAC, is going to be 270 degrees. I think we're correct. Well, if I can talk about arc BAC, then I can certainly talk about the length of arc BAC. Notice I have an arc that starts at B, goes through the point A, and ends at C. And what do you think that length is going to be? Well, I think you are correct. The length of BAC is going to be 3/4 of the circumference. What's 3/4 of the circumference is going to be 6 pi. 3/4 of 8 pi will be 6 pi. Those are two easy examples of lengths of arcs. So let me, and those two examples lead right to the formal formula to find the length of an arc. The length of an arc is the measure of an arc divided by 360 times 2 pi r. So if this measure of that arc, whatever that measure is right here, we'll let that guy be x. Whatever the measure of AB is, divided by 360, that's going to be a portion of the circumference. So the length of an arc is a portion of the circumference. Which portion is it? It's the measure of AB divided by 360. And if I go back to my previous slide, that works. If I was talking about this guy right here, well, that's 90. What is 90 divided by 360 times the circumference, which was 8 pi? That guy right there was this 2 pi. And I looked at the length of BAC. I'd have to look at the measure of BAC, which was 270, and 270 divided by 360 times 8 pi. Well, what is 270 divided by 360? 3/4, and 3/4 of 8 pi is indeed 6 pi. So these were easy portions to figure out. Now I have a formula. Doesn't matter if they are easy or not. It's the measure of arc AB divided by 360 times 2 pi r. So let's get crazy here, and let's let this guy right here, let's let the radius x be, let that distance x be let it be 5. And we're going to let the measure of arc AB equal, let's go just 40 degrees. So how do I find the length of AB? I'm going to write the formula out. The length of AB is the measure of AB, which is 40 degrees, divided by 360 times this 2 pi r. So this is the unknown that I have, the length of AB. The measure of AB is 40 divided by 360 times the radius here is 5 times 10 pi. 2 times 5 is 10. And we could simplify that, and we're certainly going to leave it in pi form. We're not going to estimate it. And we see that 40 divided by 360 is 1/9. So we have 1/9 times 10 pi. And we're just going to write that as 10/9 pi. So that's the length of AB is 10/9 pi. The length of AB is 10/9 pi. We could estimate that, but for right now, let's not estimate it. Let's just write it as 10/9 pi. Let's do another example here. Let me let this rascal right here. Let me go, that's 180. Let's go 200 degrees. Let's put another point in here. Let's put this point C, or this angle, or this arc. And we're going to go the measure of major arc BAC is going to be 200 degrees. Let's find the length of major arc BAC. Well, again, I'm going to use the formula, and I'm going to write the formula down for the assignment. We're going to want to see this formula written down each time. It's just good practice. It's the best strategy for figuring these problems out. So I'm going to write, this is what I want, the length of arc, major arc BAC. That's going to be the measure of this arc BAC divided by 360. And we know what the circumference is. If the radius is 5, the circumference is 10 pi. We figured that out in the earlier problem. And so now, what is the measure of BAC is 200 divided by 360 times 10 pi. So we're just going to reduce this fraction. If I'm not mistaken, 200 divided by 360 is going to be 5/9 this time. So I have 5/9 times 10 pi. And we're going to write that 5 times 10 is 50/9 pi. And that's the length of arc BAC. Let's make an arc right there. Looks like a big old giant segment. All right, let's do another example. Oh, so let's see. So I have 100, so I have the measure of AOB. Here's just another example. I have the measure of angle AOB is 100 degrees. OA is 4. And I want the length of arc AXB. Well, think about this. If the measure of this angle OAB is 100, then isn't the measure of arc AXB, that's going to be 360 minus 100, which is 260. And OA is 4, so the radius is 4. That says that the circumference is going to be 2 pi times 4, or 8 pi. We've used an 8 pi before. So what do we know? So we know the length of AB is going to be 260 divided by 360 times 8 pi. We know that's going to be 26 divided by 36. So we have 13/18 times 8 pi. And what is 13/18? This is going to be 52/9 pi. And we want our answers exact. We don't want to do an estimation. So that's the length of AXB. A little bit tricky. We had to first find out the measure of XAB by taking 360, subtract 100 from 360, which gave us 260 degrees. We know the circumference is 8 pi, since our radius was 4. And then we just plug what we know into the formula. Whoopsie. 260 divided by 360 times 8 pi is 52/9 pi. The other type of problem you will, and you can always pause the video, take some nice notes. And let's go to one more example for this particular. And here I have, oh my goodness. So here I have the length of AB is 24 centimeters. And I know the measure of arc AB is equal to 135 degrees. A little bit over 90. And this time, what the problem is going to ask for, hey, what's the circumference of this circle? So this time, the circumference is going to be the unknown. So we're going to write our formula out. We're going to let the length of arc AB is going to equal the measure of AB divided by 360 times 2 pi r, which is the circumference, which is what we want right there. So let's just fill in the blanks. We have the length of AB is 24. The measure of AB is 135. So I have this as 24 is equal to 135 divided by 360 times the circumference. And the circumference is what I wanted to know. So we're going to do a little bit of math here. And 135 divided by 360 is 3/8 times the circumference. And if I want the circumference, I'm going to simply multiply both sides by 8/3. So I have 8/3 times 24 is equal to the circumference. 8/3 times 24 think about this, is going to be 64. That's the circumference in whatever units. So let's zoom out and look at that problem. Complete problem, and there's the complete problem. This time I was given an arc length. I had to set up the formula. I was given the arc length, I was given the measure of the angle, and I was asked for the unknown of the circumference. So that should help us review how to find arc lengths of circles, which will be very important for the definition of a radian. Thank you very much.